Sometimes we're going to see some equations that look very complicated as we're trying to figure out what the ellipse looks like. Here is kind of one that you might see. Now, first of all, note that some of the numbers we're using, the numbers are going to kind of work out on this equation kind of clean. So they look ugly now, but we chose these numbers to kind of help you not so much worry about the numbers, but understand the process. So in this process right here, I have an ellipse. And the ellipses and that I want to translate or to move or to equate this equation to one that's in standard form. So the trick here is going to be a couple of things that involves completing the square. And so watch along with me and you can kind of get a sense of why that might be true. So first of all, I'm going to collect the x's kind of together. Collect the y's. And then drop the constant onto the other side. All right, so the first step is collect the x's, collect the y's, drop the constant on the other side. Now I'm going to complete the square for both the x's and the y's. So if we remember, there's a couple of things we kind of need to do beforehand. So first of all, I'm going to factor out of 4. Then what's left will be an x squared plus a 10. And then I'm going to leave a space right here because I know I'm going to complete that square. Then likewise here, I'm going to factor out a 36 from both of these terms. And then what's left is a y squared, 36 from 288. Use my black box here. Goes into 8 times. Leave a space. All right, catch your breath. You guys all right what we did so far? What we did is we first collected our terms so our x's and our y's are somewhat separated. This allowed me then to go ahead and look at the x's and begin to complete the square process. In order to do that, I want to have a leading coefficient of my x squared term as a 1. So I was fortunate both of these terms, a 4 would factor out, and on my y's, a 36 would factor on out. So if I were just to complete the square of x squared plus 10, how would that be? Well, x squared plus 10, to complete the square, we usually take half this middle term, which is a 5, and then square it. With this, with y squared minus 8, half this term, negative 8 divided by 2 is a negative 4. Square that, and that becomes a 16. Now, when we complete the square, we always have to take this value and add it to the other side. However, I'm not just going to add a 25 to the other side. This 25 is multiplied to this 4. So it's 4 times a 25 that I have to add to the other side. So I'm going to have to add 100. And then 36 times a 16 have to add to the other side as well. I don't need a cosine of 36. 36 plus 6, not plus, 36 times 16 is 576. All right, so the equation is still balanced. When I added a 25 here to complete the square, this 25 is really a multiple of 4, or a times of 4, and likewise is 16. I just did not add a 16, I added a 36 times the 16. All right, so what does this do for us? Well, hopefully it does something. So now we'll have a 4, x, that becomes an x plus 5. All right, that's starting to look like maybe something in the ellipse form. And then a 36. Then I have a y minus a 4 squared. Again, that's the beauty of completing the squares. Then just adding up all those numbers. Could do it in my head, but I want to make sure I don't make a mistake. Not like the black box is bulletproof because it's based on user error. 144 seems reasonable. All right. Now we're back to a previous example that we had. So this original equation that looked really messy, in order to resolve it and kind of massage it down, we did some completing the square work. Now from here, it looks like I have x squared terms and y squared terms. To get it in standard form, I have to have both sides, or I have to have the right side equaling to 1. So let's divide both sides by 144. So this term gets 144, this term divide by 144, and that term by 144. All right, to reduce this down, I'll have an x plus a 5 squared. And 4 goes 144, goes in there 38 times. 36 times. I like that number better, don't you? And then 144, so 36 divided by, not times, 36 divided by 144. 4 times. Sorry, it took longer than it should have. Four times 36, looks like that. And then 4 times 36. Oh, that's nice. They're both 4s and 36s. How about that? And all that equals a 1. All right, so it looks like we have the information that we need to have. And if I want to kind of clear this up a little bit, I know that this is going to be an x plus 5 all over 6 squared, and a y minus a 4 all over 2 squared. Sometimes people do that to identify their a's and b's fairly well. So a equals 6, b equals 2, h equals, okay, it's x plus a 5, so I need to rewrite that as x minus a minus 5. And the y minus k is already in that form. So h is a negative 5, and k is a negative 4. And the last one left is c. And so I remember that c squared equaled my larger term minus my smaller term. So that's a 36 minus a 4. C squared equals 32. C equals root 32. C equals 4 root 2. All right. I think all the hard work has been done. Now we can go ahead and start to figure out what does this graph look like. And let's find out where the center point is at first. Center point is over at negative 5 and down 4. Is that right? Well, down k is positive 4. Thank you. You guys, somebody out there caught that. So that's a positive 4. All right, so I'm going to go back a little. So I'm going to have some small tick marks here. 1. My center point is HK, which is negative 5. 1, 2, 3, 4, 5, up a 4. Right there's my center point. My vertices are, I know that my major axis, my larger number is underneath the x value right here at 36. So I know that it's a horizontal ellipse. So my major axes will be parallel to the x-axis. And so I have an A that's 6 units out from that. And this point, I don't remember what this point was. That was a negative 5, 4. So I'm going to have a point over here at 1, 4. I'll have a point over here at 6 more than 5, so negative 11. And this point was at 1 and 4. My B is 2 units above and 2 units below, so up 2 units. So that's at -5 and 6, down 2 units, -5 and 2. All right, we all right with that so far? You guys feeling pretty good? I think I'm feeling pretty good. So there's my ellipse now. Okay, imagine that's a nice, clean, pretty ellipse. And then my C values, it's along this axis right here, along this major axis, and it's 4√2 units in the positive direction and 4.2 units in the minus direction. So I'm going to have a point at -5. I got to think this through. -5 plus a 4√2. 4. That's 1 point. And the other point is -5 minus a 4√2, comma 4. Those are the 2 points. So up 4, not quite 5. So it looks like I have a point right about there and 1 right about there. And so those are my 2 foci. All right. You guys feeling all right about that? It's kind of a fun problem. It's kind of good to remember that we can still complete the square when we need to. And the beauty of completing the square, it helps us to put things into perfect squares. And who does not love a perfect square?